So let's talk about MLOps tools and pipelines. So this is a typical ML pipeline. Usually we start from data engineering to get the data prepared. And then I call the next step, which is usually data science. I call that model engineering. And then software engineering, and then DevOps. So this is sort of how WeCloudData structure our ML engineering program as well. So for someone who wants to become ML engineer, in some company, maybe you just need to focus on using PyTorch and TensorFlow to tune models. That's ML engineering as well. But in some other companies, you might need to wear multiple hats and need to do DevOps and data engineering as well, right? On the data engineering side, data labeling, it's not always the data engineers doing the labeling, because when it comes to computer vision, labeling might be a little bit tricky, and so it might be the data scientist working on that, right? But I consider that as part of the data engineering workflow, just to get the data ready. When you want to do this at scale, you may need to be working with Amazon SageMaker's API. So you actually need to write code to automate the process. And of course, data scientists want to be involved, but you definitely will want to automate as much as possible, right? Data preparation, building data pipelines and automate it, right? Creating features and put the features into feature store. And of course, data scientists will need to be doing a lot of feature selection and preparation, but data engineers will need to be involved to keep to maintain the feature store, or it could be the ML engineers. Data quality control, right? And you probably need to write unit test and a lot of testing to make sure whatever transformation functions you have, it's expecting the correct output. You want to automate the testing as well. But ML engineering is a little bit different from software engineering, right? The unit testing, the function sometimes is correct, but the data that goes into that function, transformation function, might have some problems. So your function is still running correctly. So unit testing is going to tell you that it's correct, no problem. But because of the underlying data is not that accurate, maybe the distribution has changed. So after the feature engineering, the feature has drifted. So in that case, we need some sort of mechanism to at least be able to detect that and fix the problem, right? The model might still be correct, but the prediction is not going to be as accurate as expected. So data drift, feature drift, is always a big issue in ML in production. So some people consider this as part of DevOps, or and some people consider this as part of data engineering. To me, it doesn't matter. We sort of just separate these into different stages so that the student can learn these key concepts, right? When it comes to model engineering, I think it's more about feature engineering, model training, tuning, and evaluation, right? So it's not just training our models on a laptop in Jupyter Notebook environment. In production, some companies has really massive amounts of data. So that probably means that you want to do model training in a distributed fashion using Spark ML. But for advanced, AI models, running transformers and things like that, you probably need GPU. Is GPU cluster required? GPU can be involved in distributed model training, parameter tuning as well. But in production, when you do the prediction, it's usually CPU based. Otherwise the cost of prediction is probably too high, right? So there are a lot of things that go into this decision making process, and yeah, so that's model engineering, and of course model tuning. Using SageMaker, platform, then you can do distributed model tuning, hyperparameter tuning, that can help you speed things up quite a bit. Otherwise, when your data is really big and you have very high dimension, the search space is quite expensive, then it's going to take forever, right? So, and sometimes the model is really huge, so you probably need more powerful platform. When data scientists or ML engineers, train and tune machine learning models, they're basically doing a lot of experimentation. So sometimes you may want to keep track of those experiments, right? So the model performance, some of the evaluation metrics, the model artifact in input data, where to find the data, the lineage. So ideally, we keep track of them, because over time, you're going to produce a lot of models, and a typical way of data scientists naming their models. For example, you have ML model. Let's say you're building churn model, and you have churn model underscore 1, churn model underscore 2, and then over time you're going to have churn models underscore like 99, and over time we basically just lose track of things. Don't even know, like, how do we version control basically not just your model, your code, but also the data as well, right? The data that's used for training, because sometimes you're changing the code, sometimes you're actually changing the way you do sampling, so the data will change. So I think that's one of the big distinction between, or the difference between software engineering and ML engineering, which is, it's not just the code base, it's the data. So you need to version control your data as well, basically. That's what I'm saying. That's part of the DevOps side of things. But experimentation is, keeping track of your model experimentation, artifacts, and those details. And of course, you need to save your model, and you need to decide the best format to save the model. Is it just a pickle file in Python, or is it Onyx, right? And many other formats as well. If you use Apache Spark, there's the mleap format that you can leverage. And so you need to save the model in the proper format, and that usually influence the or affect the performance in production. Because if you're using a less efficient format, the model itself, like the size might be really big, the prediction speed or the latency might be 10 millisecond higher, then your system is less scalable in that sense, or the cost will be a lot higher. And then model registry, again, that's the version control. On the software engineering side, I think model will need to be deployed. So you have to serve the model. So there needs to be some sort of REST API. Right? But for some company, if you're doing this in a microservice space, like the latency can be quite high. So you're going to use a different approach. You may want to hard code it in Java, but nowadays, I don't think you need to just hard code things. You can just find a much better way of saving your models and load that into a different language. You need to do model testing, but that includes like testing of all the functions, right? Integration testing, acceptance testing. To make all of these work, you also need the infrastructure, right? So some companies, they use Amazon Lambda functions, but maybe you want to run that in a Docker container because that's how you serve the model. Then do you need a Kubernetes cluster? Or maybe it's an overkill for your simple use case. So should we just rely on Amazon Sagemaker, which is just literally 1 or 2 lines of code? But there's some challenges there as well, because, what if you have 10 models? Do you need to deploy that 10 times? So you're going to have 10 instances running. Each instance will serve 1 model. That's probably not very efficient, but it really depends. So I think when you make all of these decisions, like there will be some sort of optimization you need to do to drive down the cost, to improve the efficiency, to make it more robust. That's what ML engineering is about, because there are many different ways to achieve the same goal, but sometimes cost is really a big concern, and sometimes the latency is a bigger concern. So and you have to make your decisions along the way. And then there's the ML pipeline automation, model data version control, and CI/CD as well, right? All right, so let's talk about these tools. This can be overwhelming, and it took me hours to create this. Just finding the right the right icons and just save them. But hopefully this is a useful graph for everyone. And it was inspired by I forgot that person's name, but I watched a YouTube video. He was presenting something similar, but I separated that into the 4 categories and added more Amazon Web Services related icons here, because we're talking about Amazon Web Services today. So in the data engineering category, just to zoom in a little bit, we talked about data labeling, right? It doesn't have to be called data engineering, of course, but I consider that as data preparation before you can even train a machine learning model, right? So you can use SageMaker, which is basically running based on the Mechanical Turk service. But there are also, Scale AI. There's open source options out there as well, and you can work with offshoring companies that can help you label data with relatively lower cost. But it all depends on how good the quality, you want it to be. Sometimes labeling data is one of the biggest challenges for startups like AI startups to get up and running. Right? They need good labeled data. And when it comes to data ingestion, right, then data will need to be ingested into data lake or data warehouse. This is the logo for Amazon S3, which is the object store. A lot of companies use it as the backend storage for their data lake. But on top of it, you can use different kind of format, right? Delta Lake, and Netflix open source the Iceberg. So that's the lakehouse architecture. These are definitely data engineering side of things that are quite exciting as well. There's also a different school of thought, right? People believing in data warehouse, right? So they're skipping the data lake here, and they believe in ELT, which is just loading everything into Snowflake first and do all the transformation in your data warehouse. Well, that's data engineering. I don't think data ML engineering need to worry that much about this. That's pure data engineering. But ML engineers are definitely going to be working with data that's stored in this kind of data systems, right? Data governance and quality. Sometimes it's data engineers who need to do that. But if the ML engineer is building the data pipeline or ML pipeline, you probably won't need to care about the data quality as well. With Amazon, on the governance side, right, you need to figure out like access control and stuff like that. There's Amazon has some data lake solution called Lake Formation. But if you would like to work with open source, just to control the data quality and great expectation is something I would really recommend you look into. You can always integrate that into your Airflow pipeline, for example, or it works with dbt as well. There's a plugin for that. So definitely look into that if you care about data quality. And data query is basically all the data transformation stuff, right? Using Apache Spark. If your company, work with Apache Spark and big data, or maybe Databricks. If your company is more like adopting a more SQL-based workflow, then dbt is really powerful. ELT or ETL tool. If you're doing everything just on your laptop, then Pandas is also pretty good. So there are many different options. For feature store, I think all the major cloud has their own version of feature store. Sagemaker has its own feature store. Google has its own, but there's also something called Feast, which was open source. But I think the team collaborated with Google GCP on that as well. There's also something called Tecton that you can look into. So these are the data engineering side of things. I hope it's not too overwhelming because there are a lot other tools you need to know. On the model training side, I think if you work as a data scientist, this is your comfort zone, right? Because you're definitely trained data scientists who know how to work with scikit-learn. Most people will start from scikit-learn and then they start to work with PyTorch and TensorFlow. Ray is something that's really nice and you can look into that. Performance is really good. I guess majority of you probably have taken fast AI courses as well. So these are the model training part. For model tunings, there are some open source projects and also managed services as well that you can look into, right? Weights and biases. Sagemaker has its own distributed model tuning service. And for experiment tracking, MLflow is kind of popular because it was originally worked on by the Databricks team, right? The Apache Spark team, basically, at Databricks, and they open source that. A lot of companies use it, but there are some other options out there as well. Weights and biases is one of them. Even DVC, like data version control, they have the model registry now, and they can help you track, model experimentation as well. So on the right hand side, you'll see model registry, right? MLflow, SageMaker, Google Cloud, they all have their own version of model registry, and DVC is something you can look into as well. So that's model engineering. On the software engineering side, and there are so many different options that you can serve model, right? Some companies will, if everything is built on top of Python stack, then maybe you can consider Flask and Fast API, right? Flask is probably not the best performing web framework, but it works, right? Deployment cost might be higher. It's not very efficient. Fast API is async based, so it's a lot faster. It's better. Building API is definitely good. But you can deploy your models in a serverless fashion as well by leveraging the serverless framework, or just deploy that to Amazon Lambda. and with the API gateway. But if you have a software engineering team, you can definitely, just write APIs using Java and whatever tool you use. You can use Rust as well, right? In some companies, if they have, a traditional data science team, right? And they don't sit next to the software engineering team and they don't have software engineer on the team. So for those companies, they actually might prefer to work with Sagemaker, which is manage the service. I think the cost might be a little bit higher, but it's super easy to use, right? When you look at the cost, on the engineering side, it might be lower because the data scientists can train and tune the models in a Jupyter notebook and deploy the model as a prediction service very easily. So yeah, and then TensorFlow serving, right? PyTorch has serving, Torch serve. These are open source solutions. But there's also Seldom, which has been around for quite a few years. There's the Kserve, Kubeflow as well. So too many options, I think. But I think every company will need to just make the right decision for themselves. It depends on their current tech stack, the team's capability and preference in terms of language, and whether they use serverless or not. So, and how much, what the latency requirement is, how scalable you want that to be. Yeah, so that's the model serving. And of course, we need to do all the, model testing, unit testing, on the coding or software engineering side. Now, the IDE, whether you're using, I think most of data scientists will be familiar with Jupyter Notebook. And if you started learning machine learning and data science from Fast AI, then you probably have heard about, MBDev, which is, a really good, dev environment created for people using Jupyter Notebook. And I think Jeremy is a strong believer of this. I heard a lot of great, comments about MBDev. But there's also different people coming from a traditional software engineering background, then they would definitely prefer, VS Code and PyCharm, right? Yeah, that's the software engineering side. There's so many tools we've introduced already. And on the DevOps side, I think ML engineers, don't really have to come from MLOps, DevOps background, because most of the company will still have the infrastructure team. So even though you work as MLOps, your focus is still on the machine learning side. So you're not a pure DevOps, right, expert on the team. There's usually platform engineering team or infrastructure team, right, which usually is in IT department. But ML could be part of product team, or could be the part of data science team as well. But on the DevOps side, infrastructure as code, right, working with Amazon Web Services, or building your models in a Docker container and deploy that, Lambda functions. But if we're talking about infrastructure as code, then Terraform can be used for managing infrastructure in different clouds. And then you need the CI/CD pipeline, continuous integration. So whenever data scientists push changes, you want to run that through some sort of automated testing, continuous integration process, and then continuous deployment as well. Some companies use Jenkins, but you can use GitHub Actions as well, or you can just go with the AWS stack, right? Using code commit, code deployment, the AWS CI/CD tool. We'll not only need to version control code, we need to version control data as well. So DVC is one of those options, but there's also some other options out there as well, not just DVC, because it's not really, it works with these, it doesn't work with massive amounts of data, basically. So, there's some other options. For workflow automation, Apache Airflow, it's not the most popular ML workflow tool, but I know Airflow is super popular among data engineers. Some companies will use Airflow to orchestrate the ML pipelines. You can definitely do that. In Amazon ecosystem, then Lambda, step functions are some of the options, but you can use SageMaker pipeline as well, which is created just for ML pipelines. There are also some other open source projects that's coming out that's created just for building ML workflow as well. The last part is monitoring, right? So monitor your ML pipelines, monitor all the features, model prediction performance. You can work with the traditional DevOps tool, Amazon CloudWatch, Grafana, right? Fiddler is one of those, fiddler.ai. But I don't think it's not free, open source, I think. So there's one open source version, which is called evidently.ai, something that's worth looking into. I didn't list all the tools here, but these are the cool ones that I think worth exploring. But that's a lot of things one need to learn. But I don't think you need to know all of these in order to become ML engineer, because a lot of things you can learn on the job as well. So so understanding the end-to-end workflow and the principle is very important, right? Instead of just learning the tools, you still need to be able to write good code. That's absolutely important. So how do we translate this into the Amazon or AWS ecosystem, right? Sagemaker does a lot of these already. For data labeling, Sagemaker has the ground truth, which is part of the Sagemaker family. And it's based on Mechanical Turk service that Amazon, that's Amazon's data labeling or whatever labeling service. It's not just for data. And for feature store, Amazon has Sagemaker feature store. On the data processing side, you can spin up EMR cluster for running your Spark jobs. If you want to do this in a serverless fashion, you can work with AWS Glue, which allows you to run like serverless Spark functions, transformations. It supports Python as well. If you just want to do ad hoc queries, then Athena is serverless based. Pretty good way to run queries nowadays. So because it doesn't really require a database for you to run queries, and it doesn't need a Spark cluster. And it's originally open sourced at Facebook, right? So it's called a project called Apache Presto, but now I think the founders of these projects started a company called Trino. So it got rebranded into a project called Trino, basically. On the data governance side in AWS, there's the lake formation, AWS IAM, a bunch of tools you can use to do the governance, access management, data protection, and things like that. And for data lake, Amazon has Amazon S3 as backend storage, but it also has Amazon Redshift, which is similar to Snowflake. That's the managed data warehousing solution in AWS. For model engineering, it's pretty much just you can achieve pretty much all of these in using Sagemaker. Sagemaker has Sagemaker experiments. It doesn't look as good as MLOps though, but it works. There's the model registry feature. They have hyperparameter tuning, which is a distributed service. You just need to provide the number of instances or number of server instances you need or virtual machines you need. Then it will automatically spin up multiple instances and do the parameter tuning in a distributed fashion. So it's pretty cool. For model training, Sagemaker has the estimator service. So in the demo today, I'll show you some code snippet, but basically it's using an XGBoost estimator. Amazon has sort of rewritten, right, these based on the open source XGBoost library to make it work with the AWS infrastructure. So it does distributed model training. It has most of the popular ML algorithms, I would say. It supports deep learning as well. So definitely worth looking into. For people who don't write a lot of code, Sagemaker also has a service called Canvas. So that's like a no code and low code ML tool that maybe data analytics professionals or product managers can use to build some model experiments. So that's the model engineering. On the software engineering side, Sagemaker has Sagemaker Notebook, but that's basically just Jupyter Lab, and Sagemaker is providing the infrastructure, right? On the model serving side, Sagemaker has an inference service, so you can use that to deploy a prediction endpoint, and you can deploy your models to generate prediction using Lambda in a serverless fashion as well. And on the infrastructure side, well, AWS itself is the infrastructure service, but it also has CloudFormation templates. You can work with the CDK or Terraform to do infrastructure as code. You can work with the Lambda using serverless as well. Version control, CI/CD, then AWS has all of these support for these as well. That's quite a mouthful. I've gone through a lot of different tools. I hope it's not too overwhelming. Maybe I can just pause here for a few seconds. So if you have any questions, feel free to let me know. And I think I have only a few more slides left. So I will basically introduce what is Sagemaker and what does the typical workflow look like, and then I'll do the demo. Okay. There was a question about Azure. Yes, Azure has similar tool, and it's called Azure ML Service. So that's kind of similar to Amazon SageMaker. And GCP has something similar as well. The recording of this session will be shared on YouTube later. We'll send you the link as well. All right, so now let's talk about data science ML at scale with SageMaker. So I think SageMaker is built or created based on the following philosophy, right? So as you work through your ML pipeline, right, you start from data ingestion and working with the raw data. Raw data is usually very big. Let's say 100 terabyte, right? And obviously that doesn't really fit onto your laptop. You can't really use pandas to do that. So you're probably going to need a Hadoop and Apache Spark cluster, right? And once the data engineer prepare the data and create some sort of features, preliminary features, right, for data scientists, the data become a lot smaller. Let's say 20 times smaller or 200 times smaller. It's 500 gig, right? The data will become a lot smaller, and maybe it's summarized into one row per customer, and you have a lot of aggregated features, right? So that table is a lot smaller. When the data scientists start to build experiments, right, start to create, to write the code and to do some sort of, baseline models, they're probably going to still need to do sampling, because working, imagine you're doing data exploration and doing some sort of visualization, even in Apache Spark. But if every query you run, you have to hit that 500 gig of data, it's going to be quite expensive. And I know Spark can do data caching, but and you can work with more efficient data store format like Parquet, right? Those all help. That's the great things about open source and Apache Spark. But still, that cost is pretty high. You're dealing with a lot of big data sets, right? So most likely, the data scientist is still going to do some sort of sampling. At least you can start with some baseline model training. So you would probably still prefer to work, in a laptop, using a laptop, right? So maybe you just do a random sampling, get 5 gig of data. Unless you train a model just using Spark ML, that's a different story. So once you have the data sample, you're going to build the models, right? Training the models on a smaller data set, like 5 gig, which usually works on your laptop using pandas and scikit-learn. And then after that, let's say we built the baseline model, we have some code, right? We would like to do the model training again. Well, this time you probably want to, you've written the code, you would like to do parameter tuning and model training on the full size data, that 500 gig of data, right? So again, you need to work with much larger data set. When you do the model evaluation, you're going to deal with larger data set. When we deploy the model, right, depending on how you would like to deploy the model, maybe it's batch prediction, right? And then you do that on a daily, hourly basis. Data might still be 500 gig. That's the raw data, right? Or whatever prepared feature that can be smaller. But if you're building a REST API to serve your model, then each input, right, that you need is probably very small, right? A couple of KB, 50 KB, kilobyte, right? So that data is very small, but it may come in, at very fast speed. So you need some sort of real-time inference, and your APIs may get hit really frequently, right? So if you look at this, pipeline, that means along the way, you're going to need different type of instances or computing resource, right, to process data at different stage. To process the raw data, 100 terabyte, you might need Apache Spark. That means you need Databricks or you need EMR cluster. And after you've done the sampling, maybe you just need a laptop to process, 5 gig of data, doing auto visualization and write the code. But when you do the model training, you probably need GPU. You probably need multiple instances to do that. Then you need GPU, right? And then model testing, analysis, and when you do model deployment, if you have a REST API, then you can always start from just one server, right? And when the traffic grows and you need to have like a load balancer, you need multiple servers to do the prediction, but still you don't need a massive, like you don't need like a compute cluster like Apache Spark. You don't need like 500 nodes to serve your models, right? But if you do batch prediction, you might as well just do that in Apache Spark as well. So anyways, you need different kind of computing power. So that's why it actually makes sense to chop up your ML pipeline, right? And you containerize each part. So it's more portable. And then you can assign different resources to process each part of the pipeline, right? So if you're running everything on Kubernetes, then you can use Kubeflow, which does exactly this, right? Loading and pre-processing the data, right? It's one step in your ML pipeline, and it's using, a few instances to do that. But when you serve the model, you just need one instance or just one Docker container, basically running in Kubernetes. And SageMaker sort of, does something very similar in this case. Okay. All right. So this is what SageMaker is about at high level. Let's say on the right-hand side, we have EMR, Elastic MapReduce. That's the Spark cluster. And obviously, we're going to use that to process raw data. And we have the SageMaker platform, right? So we have SageMaker Notebook. This is where we write code. And then we can do distributed model training, right? Running on multiple instances. And SageMaker also has the SageMaker Transform, which is batch prediction service. And it has the inference, which is the real-time inference service. So that's the REST API endpoints. Models are saved in the Docker images, right? So for each algorithm in each Amazon region, it has a dedicated ML image, right? Docker image. So and then there's a SageMaker XGBoost estimator. There's actually a Docker image for that in, let's say, the US East region, and there's one in the US West region as well. You can create and deploy your own model Docker images as well. There might be some custom code, and that's the Docker image that has all the dependencies you have in a model algorithm as well. So SageMaker allow you to bring your own models and bring your own images as well. And then of course we need a data store, right, to store your processed data, and you need a data store to store your model as well. So in Amazon and SageMaker, actually models are basically just stored in Amazon S3 as objects. Yeah, so that's how SageMaker works at a very high level. So let's go through this animation here. Let's say we have like 100 terabyte of data, and you can only do this probably using Apache Spark. So let's use Spark running on the EMR cluster. You write your PySpark code and UDF function to transform the data. And after that, data is written back to Amazon S3. So now you have, let's say, a feature data set, and data scientists will need to further process that and do more feature engineering, right? But this data set now is not 100 terabyte, it's 500 gig, right? So we have, different snapshots of data. And then the data scientist will spin up a development environment, right? That's the SageMaker notebook. So we will load the data. I'll do some sort of sampling, right? Because this notebook is just for you to write the code. So it doesn't need to be a very powerful instance. So we're going to load the sample into the notebook instance, and then you're going to write all the code, right? Visualize the data, explore the data, write your ML training code. When the training actually happens, SageMaker is basically going to launch a bunch of instances. You can start with one instance for training. It can be GPU instance, but it can be 5 different instances, so the model can be trained in a distributed fashion. Right? So SageMaker sort of handles this automatically for you. And when the model is getting trained, right, SageMaker will need to, first of all, get the containers or get the model image, or I should say the estimator image that has the algorithms, right? And it's load this image or download this image onto the model training instance, and then it creates a Docker container, and then you will have the algorithms and do the model training, right? Or you can bring your own image here as well. After the model is trained, you're happy with the performance, the model gets saved back to Amazon S3. So you have, let's say, models, and you have a folder. In this folder, you basically have a zip file. It has the model artifact, and you can load that into the production environment, or when you do the inference, for example, if you like to do batch prediction. So when you create when you want to deploy the model and create prediction, so you basically need to have a few things ready, right? You need the model artifact, like your model itself, right? And associated metadata. You need the training or model prediction environment, which usually needs to be the same as the training environment. So this is where this, Docker image comes in, right, into play. So you load that for model training, but you load that into the estimator or whatever inference service. And so you have a Docker container that's exactly the same environment, so you can reproduce the results, right? And reproduce the environment, and then you still need to load your model artifact into the transformation service or the inference, so that you can basically call the .predict function to generate the prediction, right? So that's how SageMaker works in a nutshell. Okay, that's about it. The rest of them are really just getting familiar with the SageMaker services. But today it's we don't have enough time to go through all of these. Focus on the notebook service. We'll go through a notebook, and I'll show you how to do distributed model training and how to create an inference, serving how to serve the model. But it's literally just one line of code. But if you want to do this in production, there are a lot more code you need to write. But for experimentation, it's actually pretty straightforward. Okay. Okay, so before we head to the demo, I'm going to share the demo file with you as well. This is the last few slides of my presentation. I just want to let everyone know that we have a machine learning engineering bootcamp that's starting in November, in about a month. This is how we run training. So usually we have the pre-bootcamp. So we have some course material that you can use to get prepared, and then you go through 6 months of training. It's a part-time program. So you're expected to spend about 10 hours taking classes, live lessons, and join the lab sessions. We have office hours as well. So that process is about 6 months. I think it will be very hard to become an ML engineer in 3 months. The typical bootcamp is usually 3 months, but this one is part-time based. So so if you already work in data science, and this can be quite a useful program. And as I said at the very beginning, one of the differentiators of WeCloudData is that we offer real live client projects for the students. And we usually charge for that because we hire a project team to get the project and train the students, and we still need to deliver the projects to our clients. We work with a lot of AI startups as well, so there will be some exciting projects for the students. And for this November cohort, we have a promotion, so you don't have to pay for the client project, so it's free for the students. It's a really good deal. And then after graduation, while you work on the client project, students also get mentored by data scientists working in the field or ML engineers to help you with resumes, and we help you, until you get a job. We don't guarantee offer. No one can do that. You need to put in a lot of effort as well, but at least the support will go on, and we're hoping to our students succeed. So just to give you a little bit more detail, this is the part-time program, right? It has 28 weeks of training. We help students teach students how to build portfolio project. Usually there's no real project involved. So the cost is 9,000 Canadian dollar. It's around 7,000 US dollar. Students from the United States in the program as well. We also have project only options, which is actually more expensive right now. So this is a program that helps students build real projects, right? So, and then it has career support or mentorship as well. So right now, the good deal is that we have the bootcamp training as well as the project and career services, and it's just charging you the regular part-time bootcamp fee, so you don't have to pay extra for the projects. In terms of the bootcamp, it includes it's actually 6 months, but we start from from machine learning review. We're expecting the students to know machine learning already. Otherwise, I don't think the students will be able to keep up with this program. And then we'll introduce PyTorch and basic deep learning packages. And the student will be focusing on 2 portfolio projects, computer vision and NLP. So that's the first semester. Just to get you up to speed with deep learning and some of the advanced, ML algorithms. And then in the second term, we will focus on MLOps. How come I forget about the MLOps here? But the second term is basically, MLOps, and we will cover most of the tools that we covered on this page. We don't focus on Sagemaker, but we cover a lot of the tools here, such as DVC, data version control, MLflow, Kubeflow. So we cover a little bit Kubernetes as well, with a focus on Kubeflow. We cover Amazon Lambda, how to deploy model in a serverless fashion, how to deploy your own models in Docker container using Fast API, using Torch Serve as well. We cover a lot of CI/CD, GitHub Actions, and how to do model monitoring. And of course, how to build feature store and stuff like that. So it's quite heavy program. It requires a lot of engineering skill. You need to be very comfortable learning a lot of new tools. But ultimately, this is a program that's going to benefit you a lot. And we're giving away the real client project for free this time. So if you want to add some real experience on the resume and get a reference check, this is the part that can really help you. All right, so I talked a lot tonight. So now I think we have some time left. I can give everyone a quick introduction to Sagemaker. So let me share my screen again. I'm going to switch to Chrome. So I actually have Sagemaker running already, but let me give you a quick introduction. So, right now I'm in the AWS environment. By the way, we cover AWS, Docker, and Linux in this program as well. So yeah, a quick intro to Amazon Web Services. This is the dashboard. If you click on view all services, right, it's pretty overwhelming, but because AWS can be used by many different, different people for different purposes. Data engineers will probably focus more on S3, EMR, Spark, right, data governance, building pipelines, and data scientists will probably be working with, the SageMaker service. So they have a lot of machine learning services. These are called managed service. So SageMaker is a managed service as well. So that platform as a service, meaning that you will still need to write your own machine learning code, right? But if we work with things like Amazon recognition, it's a SaaS tool, so you basically don't need to write your code. All you need to do is just provide the data, right? So the model is pre-trained. If you try the demo here, you can basically upload an image, right? And then it will do the object detection for you. So that's the label detection, right? This is just a demo, but working with recognition. So I think most likely you're a developer and software engineer, and you work in a startup. You guys don't have a data science team or ML team, but you still would like some of the cool features in your application. So you will basically be calling the recognition API, similar to some of the Microsoft Azure and Google GCP API, to label images, right? Let's say your app collects a lot of images, you're sending them to Amazon, and if your stack runs on AWS, then your image is already probably in S3. Then you can call this API to get those predictions, which is pretty cool. But that means you don't really need to have a data scientist in this case, right? Sagemaker is different. It's a managed platform as a service tool, so you still need data scientists to create notebooks, right? And to be able to train models, because I think those out-of-box solutions may not work for many companies because they need a lot of customization and they just don't trust automation yet. I don't know, maybe it's going to become really good in the future. But different companies will have different, like even though they're in the same industry, like let's say two different banks or fintech companies, their business rules and policies might be different. That probably means that the way they train models will be slightly different because of all of those policies and rules. So they want someone to be able to customize their model, right? So in this case, SageMaker is one of the options, right? But of course, you can do everything using Python, but you still need to like figure out how to deploy that yourself. And most data scientists, I would say, wouldn't enjoy working with the infrastructure, right? They're expecting to be able to like open a Jupyter notebook or access the Jupyter notebook in the cloud, and data is ready somewhere, and they start writing code and start training the models, right? So people typically don't want to deal with infrastructure. ML engineers will probably need to be able to work with infrastructure more. You will need to work on workflow automation. You don't need to be DevOps who built the infrastructure, but at least to be comfortable with working with different infrastructure tool. But in this case, SageMaker is pretty straightforward. We're using the GUI, right? So just working with the console here. But everything we do here, every button we click here, they have an API that it's the SageMaker SDK that we can work with. So we can just write Python or JavaScript to automate the entire workflow. It's probably something that's preferred if you want to bring this into production, right? And again, as I mentioned, SageMaker has the ground truth service, right? Where you can actually do model labeling. So I'm just going to click on this quickly. We can create a labeling job, right? So it's basically leveraging mechanical Turks behind the scenes. So we need to provide, let's say, the location for input data sets. So we sort of need to agree on some sort of predefined format, right? Prepare the data in a way that that SageMaker is okay with, and then define the task type, whether you're going to do image classification, but you can do video, text, right? Object detection and video. That's pretty cool. But for text, you can do, let's say, labeling for sentiment analysis, right? So you can do basically text classification, positive, negative, neutral, right? So you can use SageMaker to label your data, for model development, we can start something called notebook instance. So I'm going to click on notebook instance. So I have created a notebook instance. As you can see, there's a link on the right hand side. I can either choose Jupyter Lab or Jupyter, but it's running on the Jupyter kernel. So I have the Jupyter Lab open already, right? So now this is the environment that data scientists are very familiar with, right? Either Jupyter Notebook or Jupyter Lab. And I have a notebook that I'm going to share with everyone at the end. But this is a notebook. I'll quickly go through that to tell you how to work with the SageMaker API. But yeah, that's the SageMaker notebook instance. Coming back to the slide. This is the SageMaker notebook instance, right? We can use it to write code and develop your model. Okay. When we start to train a model, it's actually not running on the notebook. And of course, you can use scikit-learn XGBoost running on this instance, but you can choose to create something called the SageMaker estimator, right? Which is just a wrapper. And it includes, the backend code to launch the infrastructure necessary, right, to train the models in a distributed fashion. So that sort of takes away the complexity away from data scientists, right? So you can just call the API to do that. So that's called a training. So there's training algorithms, right? You can use existing or built-in algorithms provided by AWS SageMaker. You can create the algorithm and bring your own containers as well. But it's probably better to just do that using Python to call the API. When the job is running, it's calling something called training job, right? And so I've done a bunch of training jobs in the past, and as you can see, these are the training job was basically a pipeline, right? So it needs to launch the infrastructure. It will need to deploy the or download the Docker image, start a container that has the XGBoost algorithm, load the data, start the model training process. And then after the model is trained, it will save the model back to S3 and it will terminate the instance automatically. And it only bills you or charge you for 137 seconds, which is the actual model training time. So that will help you save cost because so it does this automatically. So you don't have to because sometimes when you work with AWS services, you realize that 1 week later, you realize that you have an instance running and you forgot to terminate that, right? So, and that accumulates the cost. So SageMaker sort of just does this automatically for you because at the end of each model training step, all you need is the model artifact and you can just recreate that. You don't need the infrastructure anymore, right? So it does this sort of automatically. As the training job, and if you'd like to do distributed model hyperparameter tuning or model tuning, SageMaker also has the hyperparameter tuning jobs that you can leverage. Once the model has been trained, if you're happy with the model, then there's the inference service, right? So you can get the model packages from what they call the marketplace. So these are a lot of the models or packages provided by companies like H2O, right? So these are the third-party vendors, and sometimes they are based on open source projects. You can bring them into the SageMaker environment as well for model serving, for example. But as I said, you can bring your own containers as well, or you can just leverage the AWS training, whatever algorithm. Okay, endpoints are basically model serving APIs. And if you have endpoints running, it will show here, but you can terminate that to save the cost if you don't need it. And there's also the batch transform job that kind of works like Apache Spark jobs, just like a UDF function that does the prediction in parallel. So that's a quick walkthrough of some of the components in SageMaker, but they have augmented AI and some other services as well. Okay, so once we have the SageMaker notebook instance running, we can access the Jupyter Lab, right? So this is the Jupyter Lab, and I'm going to upload the notebook, right? I'm going to share the notebook with everyone, by the way. So now let's say we have the notebook running, right? It's a very small EC2 instance, basically. And let me walk you through the code. So first, I'm going to do some, very lightweight data preparation, right? But first of all, we need to specify where the data come from. So the data is saved in an S3 bucket. Let me enlarge this. But it's saved in the S3 bucket called WCD SageMaker Workshop. So the data is supposed to be saved in basically, imagine it's a folder, right? And the prefix is just like the subfolders and path. So the data is saved in this bucket under SageMaker demo XGBoost. And so I'm going to just run this quickly because we will use this later. And then next, I would like to get something called execution role. Execution role, a role is basically, it's different from the IAM account, but it gives temporary access, right? For the different services to talk to each other. For example, right now I'm in this Jupyter notebook environment. It's actually running in a container, right? And I would like to access data from Amazon S3. So for this notebook running on one server to access the data stored in my S3, WeCloudData's S3 bucket, it needs the permission, right? By default, none of the AWS services talk to each other. So you sort of need to have the execution role And there's some, inside in the role, then we have the permissions defined basically. So let me run this, and it's going to, let me print this out, right? Somehow, oh, right now it says no kernel. So something's wrong with my, let me start a new one, or I can restart it. At the meantime, and let me take a look at the questions. Hey everyone, I just noticed that you cannot see my screen. Are you able to see my screen right now? Oh, perfect. Okay, maybe that was just for a few seconds. Okay, cool. Okay, let me run this again. I'm using Anaconda, so it's not it has nothing to do with PySpark, but in SageMaker you have the option to run the Spark kernel as well, so you can use PySpark. Okay, so this is the execution role. I call that the WCD SageMaker workshop role. So it only has the permission to access one folder, which is this folder, right? So I can do fine-grained access control. So whenever someone like access this development environment running the Jupyter notebook, it can only read data or write data to one of the folders. So it doesn't have the permission to read my other production buckets or S3 folders. Okay. And we create the role when we launch the SageMaker service, or a role can be predefined and created and assigned to you, so you can use that. Okay. So this is a Jupyter notebook running in the, in SageMaker, right? So I'm going to download the data. So in this case, just for demo purpose, I'm just going to download the data from the web, from the UCI repository. So this is the code, right? Just to download it. But again, I'm running this Linux command line in the Jupyter notebook, but you can, you can do that from the command line as well. So after the data is downloaded, I unzip that. So now we can see we have a bank additional folder that has two CSV files. So that's what we need basically oh, I think I made this public and someone was trying to access the same link. I'm going to share the notebook with you, so don't worry about it. All right, so that's the so now we have the data downloaded and the folder unzipped, right? So again, I'm going to just use pandas to pre-process the data, right? So let's read the CSV and display the data. Right? This is what the data look like. It's similar to the Kaggle data set. And the Y is the label, and it's a marketing campaign data set. We're basically predicting if someone is going to respond to a marketing message or offer. Right? And then we'll go through the typical data exploration, data pre-processing stage. But if you know machine learning, then this will be super straightforward, right? We're going to do some data exploration, to do this univariately, and then you can do the correlation matrix. But there are a lot of things you can do here. This is not a machine learning workshop, so I'm going to skip some of these details and focus on SageMaker. Okay. You not only explore the features, we can explore the target variables as well, right? So look at the distribution, and then we can create the correlation matrix. So this is going to take a while to run because this is a very small instance. So I'm just going to show you, right? This is the typical Pandas stuff, right? And then we will prepare the labels, do some sort of dummy coding, or it's probably better to use the some other feature encoder, and like one-hot encoding, right? And then we're going to drop the columns that we don't need and do the train test split, right? So in this case, I'm going to split data into train validation and test using NumPy split. I didn't use the scikit-learn train test split because I would like to split them into 3 subsets, okay? And then the reason why I do this is because I created one training data set, one validation, and for the test data set, right, I just remove the label because this data is labeled, right? So I removed the label from the test data set because later I would like to use this to to call the model prediction service. So we're assuming that it doesn't have label, but it actually does. Just to prove a point here, it doesn't really matter. So that's why I renamed that to score.csv. So this is like the scoring data set. It doesn't have label. I've already dropped the label, right? And then we have the train and validation, or you can call it train and test data set that will be used for model training and parameter tuning, right? So create that, and then I'll upload the data back to Amazon S3. Now this step is important because later on we're going to, let me go back to the slide, right? So this is where we are right now. I've downloaded a data set, right? So I have a data set here, okay? I'm uploading the data set back here because later when we do the training, right? It's launching a bunch of new instances, okay? So imagine these are different environments. This is one Docker container. This is a separate Docker container. They don't really share data, right? So for this new Docker container, right, to train the models, it needs the data. So that's why I'm uploading the data back to S3 so it can be read back into this container later. So S3 is actually playing a very important role in AWS ecosystem, for SageMaker as well. Okay, so but usually I don't think this is necessary because the data has already been prepared and it's stored in S3 already. But the reason why we do this is because in this case, I downloaded a data set from the web. So I'm sort of uploading it back to S3. Okay, so this is like the starting point. Now we have data saved back to S3. If you're not familiar with this code, it's okay. Just so you know, we're using the Boto 3, which is the Python SDK for Amazon, for AWS. So you can use that to control different services. And in this case, we're working with S3 resource, right? We had a variable called bucket. So I'm basically uploading it back to this bucket, this folder, and I'm going to call that train.csv and .upload. And this is the actual file that's stored on this instance right now. So I'm uploading back to S3, right? There's not much like feature engineering I did. And now let's move on to model training. And so let's say we would like to train a model, but we need ML algorithm first, right? So we're not using scikit-learn in this case. The algorithm we want is the SageMaker estimator. So we need that training environment, and that is not available on this Jupyter Notebook instance right now. So when we do the training, just so you know, it's training the model remotely on a different instance. That can be a GPU instance, or when you need 100 instances to do distributed training on really massive data, you can do that. So the actual training doesn't happen in this notebook, but it can still do like training locally, but this notebook is not going to be very powerful. So we can do the baseline model, right? But if you want to train on at a large scale, you still need the SageMaker, the training service. Okay, so that's why we need to get the container first, right? Or the image, right? So from SageMaker estimator, we're going to import the image URIs, and we're going to retrieve that container. But in this case, the dot retrieve doesn't really download the image. It basically just give you the ID, or the link to get that that image from Amazon ECR, right? So container, this is the Docker container location, right? This is account ID, but DKR docker.ecr. ECR is Elastic Container, right? Registry service, kind of like Docker Hub, but that's the AWS version of it, right? And the estimator is XGBoost version 1. Okay, so once you have this object or this variable, you're going to pass it along to the estimator when you actually start training the model. So we'll use that later. Okay, and then so we're basically starting to create a bunch of variables that we're going to need for model training. First, we need to tell SageMaker estimator, where do we get the container that we need for model training, right? And then we need to tell SageMaker estimator, where do we find the data? Okay, so the data, we need to sort of create the training and validation data set. So SageMaker has a training input, right? So you can define the training input. This is the S3 path. The content type in this case is just a CSV file. So we have the training and validation data set, basically, right? So we have the input train, input validation. That's really just a link to S3 bucket, okay? And then we can start the training process. I think I didn't run through all the code, so I may run into error, but it doesn't matter. I just want to show you how it's done, right? This is the actual model training code, a very simplified version. But first of all, we get the SageMaker session. We need to build an estimator. Now in scikit-learn, then that's basically the the decision tree or XGBoost classifier, right? So in AWS, it's called the estimator, and it takes a bunch of like parameters, right? Container. That's the link to the actual training image on ECR. The role, make sure that you have the right permission, because this training instance needs to access S3, so it needs the permission as well. How many instances you need? If it's one and it's just local training, if it's set to 2, then it's going to do distributed training. So SageMaker is going to launch 2 instances, right? You can specify the EC2 instance type. That's the ML instance. Where do you want to output the data? So again, the model output is saved to S3 as well, right? So let's see if I can show you. But let me start the training first, right? And then we can set the hyperparameters, and then again, model like xgboost.fit. So this part is kind of similar to other packages, right? So now let's take a look at the logs. So first of all, it's going to start the training job. And then right after this, it's actually going to launch the EC2 instance, right? The hard, like the infrastructure that's needed for this training job. And then it's going to find the Docker image, download the Docker image, and then it also needs to download the data. So let's wait a few seconds and you'll be able to see that in the logs, okay? And of course, at the meantime, we can come back to the SageMaker training service, right? If we go to training jobs, then we see there's one training job in progress. So you will be able to see, some of the log information as well. But SageMaker has a SageMaker pipeline as well. It has a sort of GUI-based tool. So over the years, it has added a lot of new capabilities, but this is one of the very basic ways of, launching in, a Jupyter Lab notebook and just, have a Jupyter notebook environment, and you can basically create your code and call different APIs to run the training jobs, right? So right now it's preparing the instance for training. So that means it needs to start the EC2 instance, and then it needs to do some preparation to set up the environment, and then it will start to download the image, start a container, and then it will need to download the data set, and then we'll run the training, right? After the training is done, it's going to terminate the instance because you don't need it anymore. So you stop paying. So you only pay for the, the training time, okay? And once the model is trained, then you have this XGB object. This object now will have the parameters, right? And the model itself. And then you can call xgb.deploy. So this means we're going to deploy an inference API. And again, it needs infrastructure, right? So as I told you, that part is pretty straightforward. So you're going to launch an instance service, and SageMaker automate this process for you. So you don't need to write your fast API or whatever Node.js code anymore, right? So it will automatically launch the infrastructure. It will download the model artifact. It still need the training or model prediction environment. So you still need that Docker image, and then it will automatically create the endpoint for you. So that's basically just one line of code, right? xgb.deploy. It works in many scenarios, but a lot of companies will need customization. For cost saving perspective, on one server, they may want to run multiple estimators. And this is when things are going to get a little bit complicated, and you find that SageMaker is probably not as flexible as you want. And so that's why some companies will want to build their own. But for many teams, this might actually just work very well for them already, right? And the rest of the code is really just loading some, that data set, and use that to do some prediction by calling the endpoint and do some sort of model validation. and you can run the batch prediction as well. So you can retrieve a model that has been already, created. For example, we have XGB underscore saved. That's basically a saved model, right? So you don't have to retrain the model every time because the model is saved in Amazon S3. So you can load it back, right, by running estimated dot attach. As long as the model that's associated with a specific training job, and you get, you put the name there, and then you get basically load them out back, and then you can run a transformer. Now, this is not the NLP or deep learning transformer. It's like just model prediction, kind of like the transformers in Spark. Yeah, that's pretty much it. And at the end, you can destroy the environment if you don't need it. So you can delete the model, delete the endpoint, and you can close the notebook. So that's a very quick introduction to SageMaker. So I think that wraps up my my talk tonight. So I think we have a couple of minutes left. If you have any questions, feel free to ask. I'm happy to answer your questions. Let me share the link with everyone. I think I put it on Google Drive. So one second. So here's the link. Feel free to download the notebook. You do need a SageMaker environment though. So yeah. Thanks everyone. Any questions? Or if you have any questions about WeCloudData's ML Engineering Bootcamp, feel free to let Wani, or you can just go to the website or scan this barcode. You will be able to find all the details you need. Come and talk with us, and I will help you decide if that's the right fit for you. Oh, thank you, Sonny. No problem. It's my pleasure. If you're interested in ML engineering, we have some other events. So we'll have a panel discussion. You'll get to meet our faculty team, and we have some career panel discussion as well. So you can come and talk to the industry experts, and get their suggestions and advice on how to become an ML engineer. And here's the link to the website. Okay, so it looks like there are no further questions. So I would like to thank everyone for your participation in this presentation and this workshop, and thanks for your patience. And I hope the introduction to